So in this section, we introduced the bridge design pattern. We said that the definition given by the Gang of Four to this design pattern is a bit unclear, where what we're saying is that we're decoupling the abstraction from the implementation so that the two can vary independently, where the abstraction refers to the abstraction and the refined abstraction, which is some control layer or some behavior, some logical component that uses, manipulates, controls another component. And that component is the implementer and the concrete implementers. And when they are decoupled, then they can grow and morph independently, and we can combine them in any way we want without having to create dedicated classes of all the various combinations that can be. We then built the class diagram in which we had the abstraction, the refined abstraction, the implementer, and the concrete implementers. And we said that we can now combine each one of the refined abstractions with each one of the concrete implementers, representing all these various combinations, where if we created a class for each one of them, then it would be much more of an overhead and the logic would be scattered across various objects and not contained just in one object. We said that the reason why this is called the bridge design pattern is because this forms sort of a bridge, and we're bridging between the abstractions and the implementations. We then jumped into a real world example where we're building some e-commerce website that has various clothing items. And we talked about how when we have multiple views, instead of creating a class per combination of clothing item with a view, which will lead to an explosion of classes, and of course doesn't scale well and is hard to maintain. Instead of this, we thought, maybe we can use some design pattern, and that brought us to use the bridge design pattern, where we said the abstraction will be the clothing view, and the refined abstractions will be each one of the mini, the compact, and the detailed views, and we'll have the implementer being the clothing formatter, and we'll have a formatter per clothing type. We then said that what we actually have over here is the adapter design pattern. The client needs to use these methods like format title, format image, etc. And what we're doing is we're taking the shoe and we're adapting it to what the client needs by creating a formatter, which is the adapter, that takes the shoe and makes the interface compatible with the client. When we put the two diagrams one next to each other, then we can see it really does follow the exact same pattern. We have the client needing to use methods like format image URL, format title, format description, and we're using the formatter as the adapter to take the shoe and adapt it to the desired interface. The bridge design pattern is one of those patterns that can be a bit hard to comprehend at first, so don't worry if you're still processing what we're learning. What I want us to do now is to write everything that we talked about up until now in code, and hopefully this will give you the holistic image of this design pattern. Let's implement the bridge design pattern. But real quick before we do that, I want you to notice that over here we have various folders corresponding to the various subsections. In the previous section, we created the various class diagrams. They exist in the corresponding folders over here. And if you want to get the source code, then in the beginning and end of each section, like with any course on Train, you'll find a zip file that you can download, unzip, and you'll have the code or the resources as they were at that stage. If you want to follow along what I'm doing now, then download the zip file that you have in this subsection because it's 3.1, and you'll have the same state that I currently have on my screen, and you can write the code together with me. So now let's implement the design pattern. So in the bridge design pattern, like we said, we have 4 components. The first component that we have is the abstraction. The second component is the refined abstraction. The third is the implementer. And lastly, we have the concrete implementer. So starting with the abstraction, then we have an abstract class called abstraction. And over here, we'll have a protected implementer, which doesn't exist yet. And we'll call this implementer, and this will be a property. So now let's add the implementer. So let's create over here an interface and call it implementer. And now that we have this, then we have the abstraction class compiling successfully. Now let's go to the refined abstraction, and this will be a concrete type. This will be the concretion of the abstraction. So let's call this the refined abstraction. And this, of course, extends the abstraction. And finally, we have the concrete implementer, which will also be the concretion of the implementer. So let's call this the concrete implementer, and this implements the implementer. Now, the entire premise is that we can have various concrete implementers. So let's call this concrete implementer 1, and let's duplicate this and create also the concrete implementer 2. Likewise, for the refined abstraction, let's call this the refined abstraction 1, and let's duplicate this and also create the refined abstraction number 2. Now, just to make this a bit more interesting, let's imagine that we have here some methods as well. In the abstraction, let's add here some methods. So let's say we have a method, and let's simply call it food that doesn't return anything and is an abstract method, meaning that both the refined abstractions need to now implement this. So let's say over here that we're implementing the foo method, and same goes over here. And what each one of these foo methods will do is it'll use the implementer that it has. So let's go to the implementer and let's add over here some method. For example, let's simply call it print or something like that, that returns nothing. And now we can go to the concrete implementers, implement the interface, and over here we can say console.writeLine and print over here hello from concrete implementer 2, and let's copy this entire thing and paste it over here, and we'll change the 2 to a 1. So again, what we have is as follows. We have the implementer with the print method. We have the 2 concrete implementers simply printing some message to the screen. We then have the abstraction, where the abstraction holds an implementer, which can be either the concrete implementer 1 or the concrete implementer 2. Now, in the refined abstractions, then in the foo method, then each one of them has an implementer, we don't know which, and we can use it over here. So we can say that we're calling implementer dot print, and this will print 1 or 2 depending on the concrete implementer. Likewise, let's copy this and let's say that over here we're also printing something to the screen, but also let's add over here something just so this is a bit more interesting and we have different implementations for each one of the refined abstractions. So let's say that over here, the entire message has 2 lines before and after. Now that we have this, then back in the client code, we can have over here our abstraction, and this is the, let's call it just abstraction, and let's use the correct namespace. And this can be either the refined abstraction 1 or 2, but whatever we choose, of course, we also need to add a constructor that passes the concrete implementer down to the abstraction base class. So let's say that we have over here the implementer, and this is passed down to the constructor of the abstraction. Over here, let's also add the implementer, and let's say that this equals the implementer that we get. Let's do the same for the refined abstraction too. Let's add here the implementer and pass it down to the base class. And now whatever refined abstraction that we instantiate, we need to also pass it an implementer. Over here, again, we can pass it either the concrete implementer 1 or concrete implementer 2, whatever we choose. Whatever combination that we create, this will have a different printing to the screen. Right now, what we did is we hard-coded what refined abstraction we're using and what concrete implementer we're using, but this can also be dependent on configuration, on different logical flows in your system. The underlying idea is that you can now represent various objects, but you have each one of the objects separated and can grow and morph independently, and the client can combine them as they wish, resulting in different behavior overall. So if we go ahead and we call abstraction.foo, then because we have concrete implementer 2, then this will print this message to the screen without the formatting around it. But the client could have also had refined abstraction 2 with concrete implementer 1, which would result in a different end behavior, this time with the formatting around and the implementer one. If at this stage of the course this still seems a bit complicated to you, then I want you to reopen the class diagram, review the code that we just wrote together, make sure that you understand what we're actually doing here, what the behaviors are, how each one of the refined abstractions in runtime will eventually hold a different concrete implementer. And only when you feel like you understand this well, then I would recommend for you to move to the next subsection in which we'll implement Dome Train clothing. There's actually one last thing that I want to do, and that is to create over here two folders, one abstractions and one implementers, and move the abstraction files to the abstractions folder and to move the implementer files to the implementers folder, just so we have this a bit more organized. Now let's implement the Dome Train clothing example.